Today we're going to be looking at line segments. So a line segment is a measurable part of a line that consists of 2 points called endpoints and all of the points between them. The 2 endpoints are used to name the segment. So you know that for any 2 real numbers a and b, there is a real number n between a and b such that a is less than n is less than b. This relationship also applies to the points on the line. It is called betweenness of points. So let's go ahead and let's take a look at example 1. So example 1, find the measure of line segment XZ. So XZ is the full thing. So to find that, we have Y that is between XZ. So what we're going to do is we're going to do XY plus YZ equals XZ. So we have the distance here. We have the distance here. We can add the 2 distances up and get the full thing. So the first distance, XY, that's going to be 11.3. YZ is 3.8. Again, that's going to be for XZ. When we add these 2 together, we get 15.1 centimeters equals XZ. So the length of that line segment is 15.1 centimeters. Let's take a look at example 2. So it was an example where we added the 2 together to get our line segment. So we want to find the measure of QR. So QR is this part right here. So we don't know what this is. Again, Q is our between point of PR. So PQ plus QR equals our whole line segment, which is PR. Now let's plug in the information that we have. So we have PQ, that's 6 5/8. We don't have QR, that's our unknown. That's what we're trying to solve for. And then we have PR. PR is 13 3/4. So I'm going to subtract 6 5/8 from both sides. 6 5/8 minus 6 5/8. When I subtract 5/8 from both sides, I need to get a common denominator between the 2 of them. Well, I notice that the common denominator between the 2 of them is 8. So I'm going to multiply this one by 2 to get me there. So 13. 2 times 3 is 6. 4 times 2 is 8. And then I have 6 5/8. So 6 minus 5 is 1/8. And then 13 minus 6 is 7. So QR equals 7 1/8 feet. So again, I took my whole length and I subtracted it by the part that I had to find the other part. Let's take a look at example 3. It says find the value of X and BC if B is between A and C. So we have our line segment. This is A, this is C, and B is somewhere in between it. AC, so that whole line segment, this whole thing, is 4x minus 12. AB, this first part right here, is just x. BC is 2x plus 3. So with this thing, we're going to have to solve for x. So we're going to use the same idea that we had, AB plus BC equals AC plug in what we have. AB is x, BC is 2x plus 3, and then AC is 4x minus 12. So this is like solving an equation like we've done before. So plug in or collect our like terms. X and x gives me 3x plus 3 equals 4x minus 12. Get x on one side. So I want to figure out which is smaller, 3x or 4x. 3x is smaller, so I'm going to subtract 3x from both sides. Minus 3x. That gives me a 0 right here, which is what I wanted. So that's 3 equals x minus 12. I want to get x by itself, so I'm going to add 12 to both sides, plus 12. So I get 15 equals x. So I found x. Now I want to find BC. And it says BC equals 2x plus 3. Since BC equals 2x plus 3, I'm going to plug 15 in for x. So this gives me 2 times 15 plus 3. Well, 2 times 15 is 30 plus 3. So that's 33. So BC is 33. So first I solved for my unknown, which is x, and then I solved for BC, the segment that we got at the beginning. Let's take a look at example 4. So we're visiting the Space Needle in Seattle, Washington. We know that the total height of the Space Needle is 605 feet. So the total height of the Space Needle is 605. The distance from the ground to the observation deck is 10 feet more than 6 times the distance from the observation deck to the top of the Space Needle. So we got our Space Needle. We got our observation deck. And then we have the needle at the top. So whatever this is, this part down here is 6 times that, and then 10 more than that. 10 more than 6 times. 10 more than 6 times. Well, if the whole thing's 605 feet, this is going to be x plus 6x plus 10 equals 605. Collect my x's, that gives me 7x plus 10 equals 605. Subtract 10. That gives me 7x equals 595. Divide by 7. X equals 85. Find the distance from the ground to the observation deck. So this is ground. And then this is observation deck. And this is top. So we're going to use 6 times 85 plus 10. 6 times 85 is 510 plus 10. So that's 520 feet. So the observation deck is 520 feet up in the air. Before we take a look at our last example, we have another learn. So if two geometric figures have exactly the same shape and size, they are congruent. So congruent is another way of saying equal to each other. The two segments that have the same measure are congruent segments. So in this case, AB has a length of 1.7, CD has a length of 1.7. This little mark right here means that they're congruent to each other. So we say that line segment AB is congruent, equals with a little wave over it, to CD. So this is read as is congruent to. The red slashes on the figure also indicate congruence. So let's go ahead and give a problem a try where we're talking about congruence. So find the value of x if q is between p and r. So q is between p and r. PQ equals 6x plus 20. QR equals 2 times the quantity 2 plus, or x plus 6. And we know that the two segments are congruent to each other. So that means they're going to be equal to each other. So we have segment PQ is congruent to segment QR. So whatever our PQ length is, it's going to equal what our QR length is. What's our PQ length? 6x plus 20. What's our QR length? 2 times x plus 6. Distribute, distribute. That gives me 6x plus 20 equals 2 times x is 2x. 2 times 6 is 12. Get rid of the smaller x, that's the 2. So minus 2x, minus 2x. That gives me 4x, bring this down, plus 20 equals 12, minus 20. When I subtract 20 from both sides, that's going to give me 4x equals negative 8. Divide by x, or divide by 4, not x, divide by 4. Divide by 4. So I can get x by itself, and that's negative 2. So we found the value of x, which is negative 2. And that's the solution for this problem. So again, we're dealing with line segments. So take a look through the notes for today. Write a summary about line segments.